Hello again. We are going to do on this block the first demodulator with Simulink. And on this case we are going to use a remote control, a standard remote control as transmitter. This transmitter uses amplitude modulation, ASK, and this modulation is easy to demodulate in 2 stages using the radio software device. The amplitude modulation, it's very easy to generate and demodulate, but it has a low spectrum efficiency, it has low noise and interference protection, and it has a high dependence of the gain control of the receiver. It is widely used in remote controllers and low data rate transmitter. In this case we use the standard remote control, which transmit at 433.9 MHz. Well, AM analog demodulation traditionally was made with a diode rectifier and a low-pass filter. Now in SDR demodulation we have IQ signals, and we have the information of the data on the amplitude of the IQ signals. So we have to obtain the absolute value of the IQ signals to demodulate this modulation. This is very easy because it's a mathematical operation, the absolute value of a complex number. Then we have to do a small low-pass filtering to remove some noise and variation of the signal. This is easily made with an integrate and dump block, and the results is to adjust the system data rate and integration to get a clear data output. We'll see the frequency spectrum and the time scope module to see the data, and we'll test different gains and automatic gain control. This is the complete block diagram. We have the same block as before we made in the example of frequency and time, but now we have put these blocks, the absolute value and the integrate and dump. Simulink handles all the data types, and these are complex data types, and from this point they have only real data. It handles it automatically, so it's very easy, you don't have to care about anything. With this complete block we have configured the frequency of the remote control here and a constant gain of 20 that later we can change. We expect these results. This is the frequency spectrum of the ASK modulation, and this is the data transmitted by the remote control. We switch to Simulink to see the real-time circuit working. Here is the same blocks, and I only have to execute the module, and we can see here the frequency spectrum and the data, the time data, output data. Now I will push the transmitter to transmit some data, and we can see how the transmitter is making the short transmission of data, and here we can see the input data on real time. We can stop this, we can freeze, and this is the frequency spectrum with ASK modulation. It's a narrow bandwidth, and this is the data received in the time scope. You can see it's clearly demodulated, and we can make a zoom of a string of data, and we can see here we clearly can identify the different data. The key point of this demodulator are the absolute value module, which don't have any parameter, it's an absolute value, and we have fit the sampling frequency to 1 MHz, which works fairly good in most cases, and the integrator and dump has been fitted to integrate 64 samples. We can change this parameter, stopping the simulation. for example, two samples, and we will see how there is much more noise in the pulse and the modulated pulse. We can execute again. And well, we make an auto scale here, and we freeze it. And here we can see how in the pulse there is a lot of noise in the higher part, and we can move more zoom, which is the modulate signal, and the integrator can remove all this noise by changing the integrator factor. This factor is related with the parameter of the SDR sampling frequency. We change again this parameter to 64, which works fairly good. And now we are going to change the gain to different values. For example, 10. Now it's working. And now you can still see how the data has a very good signal to noise ratio. It's very clear. But the problem of the ASK modulation is that if I move the transmitter, there is a strong change in the signal amplitude on the time. So it's important to use an automatic gain control. So here we can configure the automatic gain control of the RTL to do this function. We stop the simulation, and then we put automatic gain control, apply, and then we disconnect this value. We can do comment out, and then this value is not active anymore. Now it's working the automatic gain control of the RTL. Now it's in the maximum gain because there is no signal, and you can see how when it is receiving, it's controlling the gain, and even if I move the transmitter, always the gain is constant. So the automatic gain control is controlling the gain of the receiver and mitigate the effect of the attenuation due to the movement of the transmitter. So you can see how important is automatic gain control on this device and how is working the automatic gain control of the RTL. So we have seen how it's very easy to demodulate digital signals and how powerful is the RTL and the Simulink working with frequency and time signals. Thank you for your attention.